Hi, I'm Sarah, and today I'll be walking you through some mass, mole, and particle conversions. You're probably familiar with mass, and you can imagine 1 gram of sugar. On the other end of that spectrum, that gram is composed of just so many tiny little particles. Those are atoms or molecules or ions or whatever the basis is. In this case, it's molecules because we're talking about sugars. So, that'd be molecules. But what's in between the gram and the molecules? How can we convert between those two, since we know that 1 gram is composed of so many molecules? For that, we use the mole. 1 mole is composed of 6.022 times 10 to the 23rd particles. So that's particles per mole. That is Avogadro's number, and it's our conversion factor between particles and moles. Our conversion factor between moles and grams is the molar mass. That is measured in terms of grams per mole. And we can calculate that by adding up the weights of the atoms in our molecule on the periodic table, because 1 mole is calculated so that the mass of 1 mole in grams is the same as the mass of 1 particle in atomic mass units, or AMU. So if you add up the weights of an atom on the periodic table, you'll get the weights of the atoms of a molecule on the periodic table, you'll get the molar mass of that compound. We now have conversion factors between mass and moles, and between moles and molecules, so we can do some calculations. For starters, let's calculate the mass in grams of 1 molecule of caffeine. So this is the structure of caffeine, and here we have its formula. If you add up the weight of all of those atoms, which you can do by consulting your periodic table, you learn that the molar mass of caffeine is 194.19 grams per mole. We're not going to actually add those up, but you can go ahead and check yourself by pulling out a periodic table and adding those up. So we're starting with 1 molecule, and we want to know mass in grams. So we're going to need some conversion factors. First, we're going to need to convert to moles, and then we're going to need to convert from moles to grams. Well, our conversion factor from molecules to moles is in terms of particles per mole, if you remember. That's Avogadro's number, if we see it right here. Well, since that's in terms of particles per mole, we're going to have to work in terms of moles per particle. There is 1 mole per every 6.022 times 10 to the 23rd particles. That's just the reciprocal of Avogadro's number. Now we are in moles because we can cancel out molecules and particles since they're the same thing. We'll just need to use our molar mass to convert from moles to grams. And that is 194.19 grams per mole. Cancel out moles. And what we have here in our units is grams equal to grams. So if we do this calculation, it's just 1 divided by Avogadro's number times 194.19 grams per mole. The answer we get is 3.23 times 10 to the negative 22nd grams. That's the weight of the mass of 1 molecule of caffeine. Right there. Now we can work a problem in the other direction. We just did some calculations involving the central nervous stimulant, caffeine, so here's a chemical that goes in the other direction. This is ethanol, and it's a central nervous system depressant. Also used for a lot of other things, so it's a bit of a jack of all trades. The formula is C2H6O, and its molar mass is 46.07 grams per mole. Again, you can calculate that on your own if you're interested. And now let's say you've just been given 10 grams of ethanol. I'm going to abbreviate that ETOH. And you want to know how many moles of ethanol are in that 10 grams. This will be 10.0 grams, by the way. We're going to assume that this has been carefully measured out in lab so that we can get 3 sig figs. So I'm starting with grams, and I want to solve for moles. So what conversion factors are we going to need here? We're actually just going to need 1 conversion factor to get us from grams to moles, and again, that's the molar mass. Since the molar mass is in grams per mole, we're going to need to use moles per gram, and we have 1 mole per 46.07 grams of ethanol. So if we move this over here to account for our actual number, we have grams times moles over grams equals moles, and we can cancel out grams to get moles equal to moles, which is exactly what we want. If we do that math, we get 0.217 moles of ethanol in 10.0 grams. So that was our conversion between grams and moles. The next step is to go from moles to particles. We're going to go from moles to grams. So this time we're going to use helium, which is a noble gas. And let's say that the tank next to you has given you a tank of helium. Helium has a molar mass of 4.00 grams per mole. It's monoatomic, so we don't have a structure, just one atom. The tank that they've given you, they say contains 570 moles of helium. You want to know how much that weighs so that you know if you can carry the tank back to your lab. We'll also find how many particles of helium are in that tank, just for fun. So first, to find grams, we need to go from 570 moles to grams. And our conversion factor is already in grams per mole, so that's pretty easy. 4 grams per mole. And we can cancel out moles, and we're left with grams equal to grams. So if we do that math, that will have a mass of 2,280 grams. If you're not sure how much that weighs, if you're not familiar with grams, go ahead and do a conversion back to English units and see if you can carry that. Should be pretty easy to carry that one home. Next, let's just calculate out particles, just because we can. If we have 570 moles, how many particles of helium will we have in that tank? If you remember, Avogadro's number is in particles per mole, so we already have that, and we can use it right here, 6.022 times 10 to the 23rd particles per mole. Cancel out moles, you only have particles. And if you do that math, you'll get 3.43 times 10 to the 26th particles. So in this case, atoms of helium. That's the end of my introduction to mole mass and particle conversions. So now you should be able to convert between all three of those.